Hi everyone, this is Renee, and I am here today to talk about uh, really a small thing I did, I guess on the 16th of November, in the field, I guess you could say, of astrological research. And it's been interesting, the response, um, mostly positive, like I'd say 75, 80, 85% positive. But it's also met some controversy. So I just thought I'd walk through the article or the write up, really, brief write up as science papers go, and give my perspective and maybe give some explanation of what I think happened. The link is below, um, and you can follow along by opening up that link. So the write-up is titled Earthquake Magnitudes and Moon Phases Correlate. Wow. Wow. So the idea there is that it's this ancient thing that people have been looking up at the moon, and um, following her path and her associations with worldly and internal, as well as the external events. One of the most dramatic and significant kind of world events, especially one would imagine in ancient times, is earthquakes. Maybe eclipses are another one, obviously related to the moon. But what about earthquakes? What about tsunamis? What about these literally earth-shaking events in the past, present, and future? Um, let's go to the basics of astrological research. The most foundational thing I think one can possibly look at is simple moon phases. Moon phases, something that anyone, a child, anyone can look up at the sky and say, okay, that's a full moon. Okay, that's a new moon. That's with a little bit more training, that's a quarter moon. That's a waning gibbous, waxing gibbous, etc. Um, these are discriminators, these are descriptors of the moon that would have been known in ancient times. Really, I think that moon phase astrology, let's start there if we're going to talk about astrological research, because this is the foundational stuff. This is not fancy, and yet it's potentially quite deep, I think. If we can, gosh, if we can make a connection between moon phase and earthquake or tsunami or, uh, kings being deposed and so on, then that would be amazing. And since we're just in the early throes of astrological research in the modern age, I'd say. Perhaps in ancient times, there were, in fact, we have records, we have textual records of research in astrological factors being amazing, thousands of years ago. For example, Pythagorean theorem now is on record as sort of archaeologists have found records of the Pythagorean theorem 5,000 years before Pythagoras, and trigonometry from I think 1000 BC. I was just reading a text. It's linked in my Twitter feed of it's called Tantra Samgraha, I believe, and it shows calculus being done about 1000 AD in India, and that's a great read, and that's from academic archaeologists who found that. If we want to say from the Western perspective, how do we know that? From an Eastern perspective, that's been known because it's in their culture, it's in their history. And so let's unite us just as people and as humans, as one human uh, species, and let's join histories if we can, including in astrological research. So, okay, that's a long-winded introduction to this concept at hand, which is our earthquake magnitudes correlated to moon phases. You know, again, very basic astrological research. Maybe the most basic astrological research conceptually one can do. And it just kind of, I don't know, got like presented to me through a Kaggle post. Kaggle is a funny name, but Kaggle.com is a really neat place to go to if you're interested in data sets, in data science, and want to work with other people or compete against other people worldwide in analyzing these data sets. Some of the competitions have cash prizes, like $25,000 cash prize. Now everyone in the world is going to be competing for that $25,000, but it's kind of fun. And like I just did a competition entry for dog species identification, and people around the world were submitting their answers to a set of like 10,000 pictures of dogs, and then the task was to identify each of them, or more exactly develop a matrix of probabilities for 100 species, across 100 species. What is the probability matrix for the 10,000 images of different dogs? Okay, and so I did that, and I think I am right now, I was at 69th in the world, and I think there's been more competitors since then, so I think I dropped some, but it's out of a larger pool than it was at when I was 69th. So that's an example of what Kaggle is. Well, there was someone who posted a Kaggle post. Let's see if we can open that. Here we go. All right. And it's subtitled, "Is there any relationship between earthquakes and solar system objects?" And it's a data set from Japan, but it only has magnitude 6.1 and above between 1986 and 2016. So a decent span of time, definitely. But I think also I think there's a depth of earthquake limitation. Okay, so anyway, this is how Kaggle runs, that you're presented with an earthquake, other data set. There you can run little programs called kernels, and you can have discussions. So I was inspired by this. For example, here's someone who said, and the answer is no. And he says, astrology refuted, very bold claim. This is a great example of astrology critics not being very scientific, because when you read his analysis, top paragraph, he says, I could think of two major hypotheses to test, only two, that earthquakes correlate to the time of day, the sun's relative longitude, or to the tidal phase, the moon's relative longitude. Such a relation, blah, blah, blah. Instead, we only see that there's no visible influences from cosmic forces, a bold claim, considering he's only testing his own two ideations about what cosmic forces might mean, and in fact, even that is not really done super well. It has a visual kind of depiction, and he's not demonstrating in this rather sloppy way even the things that he's claiming. and moreover, the things he's claiming there's a conceptual, I believe, mismatch to the big picture of cosmic forces, or even astrology and earthquakes, the topic at hand. He's only testing his own thinking that, oh, it's got to be either sun's relative longitude or moon's relative longitude. So this is the kind of discussion or argument or constructive criticism or something that someone could leave on Kaggle. In fact, there's some comments, and I think it's just a thanks from the original submitter of the data for this guy's attempt. And so, yeah, so Kaggle is cool. Kaggle is good. If you're interested in data science, please do check it out. Okay, talk about long-winded. Let's go back to earthquake magnitudes and moon phases. So I needed some earthquake data, and Joe from a Facebook group gave me this link, and so that was really neat, because if you open that up, you'll see the USGS, the U.S. Geological Service, their website, and it's a great website. If you go to earthquakes down here, then click on search earthquake catalog, you'll see this page. So what I did was I realized that there's only 20,000 results that this page will give you. And so there has to be some constraints, some parameters, some limitations on what you search. If I can't just get all earthquakes of all time, that's a huge data set. I mean, we're talking, I think, just say since 1900, I think that's about, I think 100,000 earthquakes per year. So that's times 115, 116 years. That's just a lot of data. So I wanted to, and this website would not give it to you, for one thing. For another thing, the data value, the data quality goes down under about 1975. And the reason is, if you click on this link, uniform seismograph was finally used throughout the world in January 1st of 1975. So let's open that up. And that's a really interesting publication from the USGS itself on the history of the seismograph network, as it's called. And if you page through this, you'll see that the worldwide standardized seismograph network was only really put in place, I think, 1973, 1974, fully operational 1975. Let's see, I think it's around here on page like 2 or 3, if you want to just jump to that. But this is in 1973, the seismology program, including ASL and WWSSN, were transferred to NOAA, which actually is here in Boulder, Colorado, where I am. And so it took a while for all the seismographs in the world to be online and operational, is the point. So I decided to limit my search of the earthquake catalog to January 1st, 1975, to what? To the present day? Why not, right? However, there's an upper limit to the time band as well, because earthquakes are caused sometimes by fracking, by hydraulic fracturing. And in fact, this link links to a USGS page describing that, where it says hydraulic fracturing with its associated quakes. All right, and so there's been hydraulic fracturing since, I think, the 1960s. However, check out this graph. This is from energytomorrow.org, which is a fracking kind of friendly industry site, and they kind of proudly depict how, in blue is oil production from fracking. And so about 2006, it really starts to open up to the most recent data in 2015. It's almost an exponential, not quite it looks like, but almost exponential growth since about 2006, 2005 perhaps. So that's why I limited, I had an upper limit of of 2005. So I went from January 1st, 1975, when all the seismographs were online, to January 1st of 2005, right before that exponential growth of fracking. Okay. So I had to further limit it because even with that time band limitation, there's still too many results if I just wanted all earthquakes. So I had to limit it further, and I was like, well, what's a serious earthquake? A lot of research is just done when I did like a 3-minute Google search of seismological kind of research. A lot of it is just done on serious earthquakes, because the earth is trembling almost all the time. It's a matter of, is it serious or not? Typically, like, is it, let's look at the serious earthquakes. If we're going to talk about earthquakes, we're certainly in the news and such going to start not with every magnitude 1 tremble, very slight buzz almost of the earth, but rather serious earthquakes, right? So what is a serious earthquake? This, if you click on where it says following this system of what counts as a serious earthquake, this is a European site similar to the USGS, but European, and they give a depiction of magnitude greater than 5.5 as the start of seriousness. There's a definition of moderate from 5 to 6, and then severe from 6 to 7, or sorry, 6 to 8 or something. You can find that definition as well, but that's not as scientifically used as, at least in Europe, as this definition 5.5 and above. And that's where, plates start to fall off a table and stuff. That's a serious earthquake. Begins right there at magnitude 5.5. So I decided, well, okay, let's just look at serious earthquakes of any depth. So magnitude greater than 5.5, depth anywhere. Although I think that if you feel it on the surface of the earth where we are, it tends to be, I think the number is 25 kilometers deep or higher, or as a maximum depth of 25 kilometers, I'm thinking. But I just thought I'd start with any depth and see what happened. Okay, I'm going to shut off my phone here. Oops. All right, so let's see what happens, shall we? All right, so this first image, if you click on it, it shows this same page here. So you type in, if you want to get this data yourself, 5.5 is the minimum magnitude. Start time, put in January 1st at midnight 1975, and ended UTC 2005, January 1st, midnight. Okay, so let's see what shakes. Sorry, that's a bad pun, I guess. What happens when we put that data in? You can just jump right to this file to download it. That's the results one gets from this process of searching the earthquake catalog with those parameters. So you can just either do it yourself on this website and get the results that way, or a lot easier, you can just go to the article itself and download the file. Okay, so let's see if I can do that. Trying to think if that's reasonable to open up a spreadsheet on YouTube. Yeah, it might be. Okay, let's see. Okay, hold on 1 second. Okay, I'm opening it up in Excel, and now I'm going to edit OBS to just allow this this Excel sheet to come up. Let's see if it'll work. My OBS studio is not letting me do that. That's too bad. I think there's a, just an incomplete program in OBS studio that I'm using. It's for some reason not letting other applications to show up. Maybe I'm making a mistake somewhere with that. I'll have to figure it out another time. But what you get is as you open that file, you'll see the first column is the time of the earthquakes, 13,623 of them, I believe, in that window of that magnitude window as well. And also in that spreadsheet is a bunch of other factors, including magnitude, but we just want to keep only those two columns: the time of each of those earthquakes and the magnitude of each of those earthquakes. And here we are, going back way to the beginning of this little talk. We're looking at moon phases. So we need to convert all those times to moon phases. So time of the earthquake and date, of course, of the earthquake. What moon phase was it? Up in the sky, or perhaps it was underground. Perhaps it was on the other side of the earth, and perhaps it was nighttime and a new moon, and so there was no nothing like nothing to see up above, but it was still a new moon. So let's look at what I think happens next, which is that we set up a sort of correspondence between each of 8, let's just use 8 phases, 8 basic phases. The full moon is well known, has always been well known. The new moon is well known, always has been well known. And then there's phases in between. So new moon becomes waxing crescent, which becomes the first quarter, which becomes the waxing gibbous, becomes the full moon, becomes the waning gibbous, becomes the third quarter, becomes the waning crescent, and then it's new moon again. So that lunar cycle has been understood for a very long time. And I think that, again, a child in ancient Greece would know these things. That there's probably textual kind of ways to find that out or to find support for that claim. But that's what I'm thinking, is that a child in ancient Greece would know these phases. All right, so I thought, well, okay, we have 8 phases, but there are different lengths, right? It's full moon for only a couple days, whereas it's waxing gibbous for longer than that. Same with new moon and say waxing crescent. I don't know why, but I thought that I should use a correlation. Well, I think that's straightforward. Why I'd want to use some sort of correlation relation between these moon phases and earthquake magnitudes. However, because earthquake magnitude goes exponentially, so there's a ton more at the lower level of magnitude and zooms quite substantially to a lot fewer. Oh, I guess the exponential is this way. So there's a ton at, like, say, earthquake magnitude 5, and then it attenuates out to earthquake 9. There's only one in the history of those 30 years where there was an earthquake of 9. I forget the date, but compare that to the thousands and thousands of earthquakes at magnitude 5. So that's a very beautiful exponential drop. So what to do with that? What correlation relation can we use for such magnitudes that have this attenuated kind of tail to them, as they're called? You cannot use a lot of correlation relations because they assume what's called normality, which means that there's a nice normal curve to the data of the magnitudes, and there's not here. There's not normality. So Pearson's correlation coefficient, for example, could not be done. What can be done? A ranking system. A ranking system. So that's where you just rank each of these moon phases in order. One rank being assumed to be like more, having more earthquakes than the one before it, and the third one having even more earthquakes than the second one, fourth one even more than the third one. But heck, these are moon phases. How can you structure a ranking system? Well, you could do it in sequence, so that, for example, new moon is number 1, waxing crescent's number 2, third quarter is number 3, waxing gibbous is number 4, full moon is number 5, waning gibbous number 6, third quarter number 7, waning crescent number 8, I guess. Okay, fine, you could do that, but there, I think people might have done that already, and there's no value to that. There's no significance, no significant correlation if you do that. I think I read that somewhere. So what? So let's try something new, something different. What about having a sense of danger be the ranking system? Well, in Jyotish, in Vedic astrology, there is a sense of discrete qualities that jump between each of these phases, so that the full moon is considered very benefic, as it's called. That's the least malefic. Again, these are technical terms. It does not mean that the moon itself is anything other than your friend. The moon is your friend. The moon is almost everything. I bow to the moon. However, in this correspondence between moon phase and danger, there is a sense that the full moon is less dangerous than the new moon, because the full moon is considered less malefic and the new moon is considered more malefic. Okay, so similarly, the waxing half of the lunar cycle is considered more benefic than the waning half of the lunar cycle. So let's consider this. If this is true, then there is a ranking system where we start with, you can, I don't know, which way shall we start? With the full moon as the least malefic, because it's the most benefic. And then what about the ones next to it, the waning and waxing gibbous phases? Well, the waning gibbous is going to be more dangerous than the waxing gibbous, because this is in the waxing half and this is in the waning half, the Krishna Paksha, you know. And so let's assign 2, the next rank, to waxing gibbous, and 3 to the waning gibbous. Similarly, first quarter and third quarter are going to be about equal, but the waxing is slightly less dangerous than the waning. So let's give the next rank to the waxing quarter and the rank after that to the waning quarter. Similarly, for the next phases, the crescent phases, waxing and waning. Waxing is going to be less dangerous than the waning crescent. And so waxing gets 6 and waning gets 7. And finally, the most malefic, you know, again a technical term, for the moon is the new moon. So let's give that the highest ranking of 8. There's, you know, we could have split it up perhaps into these, or into finer number of stages. That might be something to do next. This was really a casual study. It was really just done in a couple of hours, including making these pictures and everything, and this write-up. So that's the idea here, is that there's a correspondence between moon phase and malefic energy. That's I'm sorry, but that's Jyotish 101. That's basic foundational Jyotish idea, is this mapping of benefic energy and more malefic energy, and the idea that the waxing phase is better than the waning phases. It might be really neat to use nakshatras. Again, it might be really neat to use tidis. I just did this correspondence again fairly quickly and fairly casually, and so I was like, well, let's see what happens. Yeah, and so what happens is that over the course of 30 years of the study and 13,623 earthquakes, is there a correlation? And yes, there is. I could not use Pearson's correlation coefficient because of the non-normality of the magnitudes themselves. So I use Spearman's row rank test, which is a test for rankings, and that's exactly what we have here, rankings. And moreover, Spearman's row can be used even with non-normal data, and that's what we have here, so it's very appropriate. And you can Google Spearman's row rank test for the equations, but I found a correlation row of 0.0252, which is a measure of effect size. So the effect is mild. It's a weak correspondence. But it's highly statistically significant with a p-value less than 0.01. It's actually 0.00325. And for people who are like, well, forget about it, this has a really weak effect size, I just want to point your attention to, where is it? This page here. This is just one page of many on Wikipedia about effect sizes. There's much to be said about effect sizes, but this is what I want to leave you with, is something called Abelson's paradox, which is an applied statistics paradox pertaining to possible paradoxical relationship between the magnitude of R squared, which is an effect size measure, and its practical meaning. That's why people want effect sizes. They want something they can hold on to about practical meaning. Let me see if I can make this bigger so you can read it too. How about that? All right. So Abelson's example was obtained from the analysis of the R squared of batting average in baseball and skill level. Although batting average is considered among the most significant characteristics necessary for success, the effect size was only a tiny 0.0003, so much smaller by a tenth of my effect size for this study. And so I think the point here is that there's so much going into the idea of success in baseball that even batting average, considered like the prime measure of success, itself only has a small effect size. So you have to be very cautious with effect size interpretation. You have to realize that even Cohen, when he talked about Cohen's D, which is like the premier measure of effect size, which by the way is not appropriate here because we're talking about 8 discrete groups, and Cohen's D I think is just for 2 normally distributed groups. So we don't have normal distribution and we don't have just 2 groups, we have 8 groups. So Cohen's D is itself not particularly appropriate, but is held up as the measure of effect size, the prime measure of effect size. So even its developer, Mr. Cohen, Dr. Cohen, said that please don't don't just use some sort of 0.2 and above it's good, and 0.2 and below it's bad or something. He was quite cautious about that. But what happened? People galloped with the idea of effect size because, again, it's something tangible, something tactile almost, to use that can be used across 2 different studies and so on. But it's highly field and domain dependent, and it's highly dependent on what method of effect size you use. Going back to this study, the effect size measure is itself the correlation row, and so that being 0.0252 has to be compared to other rank test results or effect sizes, and it has to be considered within the field of geological studies itself. So also it has to be compared to the notion, even with all of that said and all of that done, let's say you do compare it to other geological studies of row rank tests. Let's say you've done that. Even with that said, this might be really significant given the context. So for example, if someday, and this is nowhere where it is right now, but let's say someday this observation were used to as a part of a planning program for preparation for earthquakes, for predicting earthquakes, then and potentially saving lives, to have a 2.52 uptick in improvement in being able to save lives is considered very good. Like if this were a cancer study, and medicine could improve um, response, positive response to a cancer medicine by 2.5%. Oh, you betcha that people would be interested in that. So it's highly context dependent, this measure of effect size. It's highly technique dependent, whether you use Spearman's row versus Pearson's versus a Z-test and so on. And it's highly, even with all of that said, uh, it's highly interpretable, uh, uh, scientific domain wise. So cancer research or life-saving earthquake prevention or like prediction measures, or compared to baseball averages or something. It's different for each field what counts as valuable. So again, just want to underscore, even with all of that said, that there is this paradox called Abelson's paradox, which shows that there can be a paradox between effect size and practical meaning. So all of this is a lot for what was a quick and casual 2-hour study. The calculations are included in PDF form. You're welcome to download those. There's some more download stuff you can read about. Finally, this is important. If you click on this picture, this is the distribution of earthquake magnitudes for each moon phase rank. So to the left is new moon. I'm sorry, to the left is rank 1, which is full moon. To the right is rank 8, which is new moon. And then in between are the ranks from 1 to 8 for each of the 8 moon phases. And you can see that with the yellow, let's start with the yellow. The yellow represents the 25th to 75th percentile sort of expectation for the results. So these have to do with percentiles. You might remember percentiles maybe from elementary school standardized exams or something. So, okay, let's use that analogy just to hopefully make this a little more digestible. So what this yellow bar is saying that the full moon has a much lower distribution of scores between the 25th and 75th percentile. And as you go to the right, that yellow bar starts to rise, right? It's a little hard to see, but it does. You can see it's at the very least it's quite low for the full moon. And then as you go through the rankings to the new moon, ranking 8, the means do increase. That's in the pink diamond. What that represents is the 95th confidence interval of the mean. So that's for people who want to just see the means or averages. That's another word for mean. And you can see that it's kind of flat between 1 and 5, and then starts to increase with 6, 7, 8. But you also have to consider the height and height of that diamond, like how wide it is, not just the flat line sort of in the middle, but how high up does it go and how high down does it go. That gives you the 95% confidence interval for that mean. And so you do see a subtle but truly rising mean as you go to the right, to the more malefic moon phases. And that's it. This is called distribution of earthquake magnitudes for each moon phase rank. If you want to learn more about how to interpret this, because there's other stuff here, obviously, you can Google, box whisker plot, also known as simply a box plot. And it's just a visual way to see distributions. And I did 8 of them, one for each of the rankings, and put them together. Good. So that's it. To conclude, a weak but highly statistically significant correlation was found between historic earthquake magnitudes and moon phase ranking. This ranking system is based on beginner astrology, about which phases are more troublesome than other moon phases. So I think that this is little study should be of interest to astrologers and others, because the explanation for this p-value highly highly unexpected anomaly in earthquake magnitudes, the explanation for this anomaly is moon phase astrology. Moon phase astrology. That is the explanation or the reason for the model of correspondence between earthquake magnitude and moon phase. There might be some other correlation to something else that also correlates to moon phase, but at the very least, this is an anomalistic correlation between moon phase and earthquake magnitude, and hence I think it's of interest. And I wanted to let you know about it. Okay, so let me know of any questions you might have. I think that's all there is to this thing. There's some nice sort of comments where I also use the same model, for example, on tsunamis, where there's a higher correlation rho of 0.04, but the p-value is only 0.19, and that might have to do with the relatively low number of known tsunamis with known magnitude and known time of occurrence. There's only 988 of those total in the whole history of the world. Earthquakes, there's a ton more, right? Just in the 30-year window I looked at, there was 13,000 of them. 13 times the amount of all tsunamis of all time of magnitude and minute known. So that's interesting, I think. Just kind of an aside. Yeah, so there's a Jyotish or Vedic astrology reasoning for why this result happened. It's worthy of some concern, some attention. I think that's about it. Yeah, p-value 0.00325, correlation rho of 0.0252, measure of effect size. So weak, but highly significant. Same as possibly that baseball example of having high significance for the batting average as part of the success of the baseball player, but it still only has a tiny effect size. The batting average does. So we have to be careful with effect size. That's about it. Thanks, guys. Bye.